This one gets crazy. Find the general solution. Oh, well, good to know. Good to know. What does that mean? That means separate, integrate, solve. Good. Great. They're plugging in. They did not give us a condition, some initial condition. They didn't give us that. So we're just going to leave our answer with the C floating around. And I'm actually looking at the answer on the answer key right now that I made previously, and it is gross. So get ready. It's going to be kind of nasty. What color should I pick? Pick one. Type it in the comments. Choose a color. Good choice. I think I will. So therefore, we will start. I'm going to rewrite that entire thing. Kind of helps me wrap my mind around it. Might be a little waste of time. I'm stalling because I don't know what I'm doing. Kidding, I do. X plus 5 squared. Okay, you're looking at that and you're thinking, what should I do? Oh, should I distribute? Don't. Please don't. Please, please don't. The title of the lesson is Separation of Variables. And if you start putting things together, you're going to have to eventually take them back apart. So don't. I need my x's on one side and my y's on the other. There is an obvious thing to do where the dx comes up here and the dy stays here. Okay, all your x's need to stay here. So 3 needs to stay, doesn't have an x, but normally, I like to take all the extra superfluous stuff, constants, for example, keep them on this side. It just uncomplicates your y. And then x plus 5 squared can go there. And then this 3 minus y needs to come to this side, and it actually gets divided. Okay? All right, let us proceed. It's going to be fun. We're going to integrate. Oh, I usually integrate with the green pen, but now I'm writing in green. We'll use purple. Integrate, integrate. Isn't it great to integrate? Integration song. Okay, let's do the left side first. And when I do, it's going to take a little bit of, get ready, U substitution. Let's switch colors again. Over here on this side, I'm going to do this so I don't just keep writing a whole bunch of steps. So the integral of 1 dy over 3 minus y. And then u would be the denominator. The derivative of u would be negative 1 dy. I don't want negative 1 dy, I want positive 1 dy, so we have this. Therefore, we have the integral of negative 1 du over u. Well, that gives me negative natural logarithm of u, and then plus c. I'm not ignoring my c. It's going to come out in the bigger process, so just bear with me. And oh, actually, that would almost be it. So negative natural log of 3 minus y. So all this, there it is. Okay, if you need to see it again, rewind the video. So negative natural log of 3 minus y. Okay, now we're going to do this one. This one actually is also u substitution, but it might behoove us if we square this, like square the binomial. I'm not going to. My answer key does have it that way when I had worked it out earlier, but I'm not. So I'm going to switch colors. I'm going to use red, and I'm going to integrate this side. So integral of 3x plus 5 squared dx. This one's going to be a little more straightforward because u, whoops, not d, but u is x plus 5, so du is 1 dx, and therefore we have the integral of 3u squared du. That's pretty straightforward. And that gives me, well, u cubed plus c. The c comes out later. We'll deal with them at some point. So I really have two, oops. This is going to unsloppy our answer since I'm leaving it this way rather than the way that I had done it previously. In case you care, look at that exponent. Just look at it. Shameful, huh? So x plus 5 all cubed, yeah, because the derivative of that would give me, well, that. It kind of makes sense that way when you look at it. So we have x plus 5 all cubed, and then plus c. Don't forget your c. All right, again, we're finding the general solution, so we need to solve this thing for y. So I think the next thing for us to do is to, well, get rid of that negative in the front that popped up because of the chain rule, u substitution, I should say. Natural log of 3 minus y equals negative, and then x plus 5 to the third. All right, minus c or plus c? It's c. It's just c. Add c. because maybe C was negative and you just changed it. Who cares? It's C. You can throw whatever you want at C. It's a constant. All right. Now we are going to get rid of this natural log by doing something I call e-ing both sides. It's not the only way to look at it, but whatever you do to one side, you do to the other. So e to the left equals e to the right. And in this configuration, e and ln cancel each other out. Long list of reasons, not for this video. Actually, I don't need the bars anymore because I'm not natural logging, so we'll take the bars out. So unnecessary absolute value, don't need it anymore. And I have e to the negative x plus 5 cubed plus c. All right, here we go. Things are about to get a little ridiculous, and this is going to happen a lot in the next lesson. So real quickly, post-it note time. Let me just use the back of another post-it note that I had drawn that on. If I had x to the second times x to the fifth, I'd really have x to the seventh, right? Good? Yeah, of course. So if I have e, and we'll call it e, we have e to the x times e to the 2, we'd really have e to the x plus 2. Cool. So if I have e to the x plus 2, I really have e to the x times e to the 2. Yeah, same thing. I could move forward. I could move backwards, right? Because I'm adding my exponents. I'm adding my exponents. My next step looks like this. E to the negative and then x plus 5 cubed times e to the c. Okay, remember, c absorbs whatever you throw at it. C is a constant. E to the c, this is a number to a number. It's a number. So this is another constant. Sometimes I kind of capitalize it at this point. It just sort of helps me, but you don't have to. So 3 minus y equals e to the negative x plus 5, and it's cubed. But number to a number is a number. Don't leave numbers dangling at the end. Put them in the front. And we'll keep solving. We're going to bring this work up here. So negative y equals c e to the negative x plus 5 cubed. Oh, it's that time of day. The sun's shining through, illuminating our mathematics. And then final answer, y equals, we're going to divide by -1, so we'll go for the obvious there. And then we could say, well, it changes the sign of the c. Yeah, c absorbs whatever you throw at it. I can't make a good rational reason for why we would change the sign and be like -c. It's just c, call it c. There we go. And that is what we get. And my answer key had it a little bit different, and I believe it is because I had distributed and all kinds of fun stuff. But that's it.